Hey everyone, so we are going to start our webinar off by talking about the two thinking methodologies that Makey really supports. So one of the main ones, and the first one that I'm going to speak to is computational thinking, which you can see from the graphic. And these are just some buzzwords that are thrown along, often with computational thinking, but oftentimes it's really difficult to quantify and put in an actual definition to see what this actually means and where it's going. So I thought it would be better if we provide some landscape of what does this really mean?
Whoop-de-doo! What does it all mean, Basil?
And exactly, when you speak to fellow educators, this often is a problem that comes up and a dilemma that they don't actually know what this means and what is the starting point. So really what it is, computational thinking is making the impossible, a reality for all learners through education. So there are a few main pillars to CT, and there are actually four main pillars of computational thinking that we are going to focus on. So really, what is computational thinking? It's these four main pillars. So it's decomposing, abstraction, pattern recognition, algorithms that really make up what CT really is to its full function. Now, in terms of the other thing, what relates to CT, we're talking about design thinking. So initially, we're talking about computational thinking, and we work into and align very well with design thinking. And I'll get to what design thinking looks like a little bit later. So we just got a little graphic here. So one of the important things to note about computational thinking is that it's not simply limited to coding. So I love this quote from Jeanette Wing that she talks about computational thinking is a fundamental skill for everyone, not just for computer scientists. The goal here shouldn't be to make computer scientists. The goal is that computational thinking and coding should be integrated in all the things that we're already doing anyways, because it provides numerous benefits, whether it be through literacy, French as a second language, you name it. Now, one of the other major benefits about coding is that it offers instantaneous feedback, meaning that when you do it, the user can see right away whether or not they've got the answer correct. And if they haven't, they can see maybe where they're going wrong, and they get to actually create an authentic and meaningful experience where they can rectify their solution or answer, which is really powerful along the way. So again, not limited to coding, we have all different industries that students may wish to go into that will involve 21st century education, whether it be technology, coding, you name it. So of course, in this picture, we do have virtual reality components, but it's sports through analytical analysis. We have farming and manufacturing, which is really translating using code and different analytical systems. Of course, you have your traditional engineering platforms, but there's a wide variety of things that will be controlled of the internet, through the Internet of Things, rather. So another element of computational thinking is that it's not simply a checklist. We don't just walk in and just go, okay, well, today's Monday, so I'm really going to do computational thinking today. It's a way of thinking and a way to empower rather than simply something to do. We do it because it's best for our students. Now, this goes into supporting design thinking. So design thinking was really started out in the business sector of a way of creating something that could be more effective to create a more desirable outcome. So this also supports students with executive functioning really well because it breaks down problems into smaller, more understandable segments, making it a lot easier for these students to be supported and perform better in all aspects within the educational landscape. So we put up this graphic, but normally design thinking is often referred to as like a methodology, and it's used by designers to solve really complex problems and find desirable solutions for clients. So design thinking really draws upon logic, imagination, systemic reasoning to explore possibilities of what could be and to create desired outcomes for the benefit of the end user, as I mentioned. Now, this graphic is really great for design thinking, and the reason I like this is because oftentimes when you relate and think of computational thinking, it's really hard to define it. And how I normally explain computational thinking is that computational thinking is the way to think more effectively in such a way that a computer would do. So more thinking like a computer by breaking problems down into smaller segments to create a favorable outcome. Now, that's all well and good, but that's really hard to explain to someone else oftentimes, and that's not quite even just it. But what I love about design thinking is that there's an actual model. So this model talks about empathizing with a given situation. So you see a need out in the community, you empathize with it, and you want to try to help. So you recognize that part. The second stage in design thinking is defining a problem. So you empathize with it, but now you can actually really pinpoint what that problem is. Your next step in the process is to go about how can you generate an idea that would solve this problem. And a lot of teachers are using this model now, like in Genius Hour projects or any project-based learning environment, in order to create a given solution. And one of the great ones is the UN Sustainability Goal model right now that teachers are often using with like the Microsoft Make Code project. And once students have an idea, you would then move on to the prototype stage where you're designing and students are working collaboratively, connecting, using their creative aspects and those global competency skills in order to generate something that's most likely tangible. And then we go into the test phase. Now, one of the best benefits about this is that you can really see it and break problems down. The only thing is when you make a model like this, and I was really excited, okay, this model's done, it looks great, but then I realized something. It's incorrect. And the reason it's incorrect is because you can probably imagine if you do something with your students, it doesn't work in a linear fashion all the time. This model should really be cyclical in a circle because this is a continuous model. Because if you're going through it and you think of someone like Alexander Graham Bell who's trying to work on the telephone, I'm sure that the situation wasn't like, okay, well, I know we need the need for communication. I'm going to define it. We're going to create this device, and the device is going to be a telephone. Here's the prototype. I tested it first time, it worked. No, there's a lot of failure that goes along the way, and we want to embrace that failure. So this is going to be the first portion of your video with a series of questions. So that's going to conclude it. Please answer any questions you may have, and if you do have additional questions for me, please feel to reach out, and I will be happy to help you. Thanks, guys.